Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Cloud Architect certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
Mount Kirk Games has deployed their new backend on Google Cloud Platform, GCP. You want to create a thorough testing process for new versions of the backend before they are released to the public. You want the testing environment to scale in an economical way. How should you design the process? The options are: Option A, create a scalable environment in GCP for simulating production load. Option B, use the existing infrastructure to test the GCP-based backend at scale. Option C, build stress tests into each component of your application using resources internal to GCP to simulate load. Option D, create a set of static environments in GCP to test different levels of load, for example, high, medium, and low.
To arrive at the correct answer, we focus on the keywords: backend on Google Cloud Platform, GCP, testing environment to scale in an economical way.
The correct answer is Option A, create a scalable environment in GCP for simulating production load.
Why is this correct? A. Creating an on-demand, scalable environment in GCP allows testing under simulated production load without paying for persistent static infrastructure. Resources scale up during testing and down when complete, fulfilling both thorough load simulation and cost efficiency. Why are the others incorrect? B. Using legacy on-premises or existing non-cloud infrastructure lacks the elasticity required to test cloud-native scale efficiently, introducing network latency bottlenecks and hardware limitations that prevent realistic production load simulation. C. Embedding stress test logic into application components inflates application overhead, complicates code maintainability, and fails to simulate true external client traffic patterns under realistic end-to-end load. D. Maintaining static environments for high, medium, and low loads incurs continuous infrastructure costs for idle resources, violating the requirement for an economical scaling solution.
Mount Kirk Games wants to set up a continuous delivery pipeline. Their architecture includes many small services that they want to be able to update and roll back quickly. Mount Kirk Games has the following requirements. Services are deployed redundantly across multiple regions in the US and Europe. Only front-end services are exposed on the public internet. They can provide a single front-end IP for their fleet of services. Deployment artifacts are immutable. Which set of products should they use? The options are: Option A, Google Cloud Storage, Google Cloud Dataflow, Google Compute Engine. Option B, Google Cloud Storage, Google App Engine, Google Network Load Balancer. Option C, Google Kubernetes Registry, Google Container Engine, Google HTTP/S Load Balancer. Option D, Google Cloud Functions, Google Cloud Pub/Sub, Google Cloud Deployment Manager.
To arrive at the correct answer, we focus on the keywords: continuous delivery pipeline. Services are deployed redundantly across multiple regions in the US and Europe. Only front-end services are exposed on the public internet. Single front-end IP for their fleet of services. Deployment artifacts are immutable.
The correct answer is Option C, Google Kubernetes Registry, Google Container Engine, Google HTTP/S Load Balancer.
Why is this correct? C. Container Registry provides immutable container image artifacts. Google Kubernetes Engine supports microservices with fast updates and rollbacks. The global HTTP/S Load Balancer provides a single global external IP address routing traffic across multi-region frontends while leaving non-frontend services private. Why are the others incorrect? A. Dataflow is designed for stream and batch data processing, not serving microservices. Compute Engine without an HTTP/S load balancer cannot provide a single global front-end IP address across US and Europe, nor does it natively store immutable build artifacts. B. App Engine does not natively store immutable deployment artifacts like container images. Additionally, a network load balancer operates at layer 4 and is regional, failing the requirement for a single global IP address across US and Europe regions. Cloud functions in pub/sub are event-driven components for asynchronous processing, not designed for hosting front-end service fleets with a single global IP. Deployment Manager manages infrastructure provisioning rather than serving front-end application traffic or storing container images.
Mount Curt Games gaming servers are not automatically scaling properly. Last month, they rolled out a new feature, which suddenly became very popular. A record number of users are trying to use the service, but many of them are getting 503 errors and very slow response times. What should they investigate first? The options are: Option A, verify that the database is online. Option B, verify that the project quota hasn't been exceeded. Option C, verify that the new feature code did not introduce any performance bugs. Option D, verify that the load testing team is not running their tool against production.
To arrive at the correct answer, we focus on the keywords: gaming servers are not automatically scaling properly, 503 errors and very slow response times. What should they investigate first?
The correct answer is option B, verify that the project quota hasn't been exceeded.
Why is this correct? B. Exceeding project quotas, such as compute instance limits, prevents autoscaling mechanisms from provisioning additional servers to handle traffic surges, directly causing capacity shortages and 503 errors. Why are the others incorrect? A. An offline database would cause database connection errors or 500 internal server errors across requests, rather than causing autoscaling failure during traffic spikes. C. Performance bugs within application code can slow down responses, but they do not prevent autoscaling infrastructure from launching new instances. D. While load testing against production adds unexpected traffic, it does not explain why the autoscaling service failed to scale up resources.
Mount Curt Games needs to create a repeatable and configurable mechanism for deploying isolated application environments. Developers and testers can access each other's environments and resources, but they cannot access staging or production resources. The staging environment needs access to some services from production. What should you do to isolate development environments from staging and production? The options are: Option A, create a project for development and test and another for staging and production. Option B, create a network for development and test and another for staging and production. Option C, create one subnetwork for development and another for staging and production. Option D, create one project for development, a second for staging and a third for production.
To arrive at the correct answer, we focus on the keywords: deploying isolated application environments, cannot access staging or production resources, isolate development environments from staging and production.
The correct answer is option D, create one project for development, a second for staging and a third for production.
Why is this correct? D. Google Cloud projects provide the primary boundary for IAM isolation and resource management. Using separate projects for development, staging, and production guarantees strict environment isolation and fine-grained access control. Why are the others incorrect? A. Combining staging and production in a single project violates security isolation and prevents fine-grained IAM controls between staging and production resources. B. VPC networks only handle network routing and do not provide IAM isolation or permission boundaries to restrict user access across environments. C. Subnetworks merely segment IP spaces within a network and offer no IAM access control or security boundary for isolating environment resources.
Mount Curt Games wants to set up a real-time analytics platform for their new game. The new platform must meet their technical requirements. Which combination of Google technologies will meet all of their requirements? The options are: Option A, Kubernetes Engine, Cloud Pub/Sub, and Cloud SQL. Option B, Cloud Data Flow, Cloud Storage, Cloud Pub/Sub, and BigQuery. Option C, Cloud SQL, Cloud Storage, Cloud Pub/Sub, and Cloud Dataflow. Option D, Cloud Dataproc, Cloud Pub/Sub, Cloud SQL, and Cloud Dataflow. Option E, Cloud Pub/Sub, Compute Engine, Cloud Storage, and Cloud Dataproc.
To arrive at the correct answer, we focus on the keywords, real-time analytics platform, which combination of Google technologies will meet all of their requirements.
The correct answer is option B, Cloud Dataflow, Cloud Storage, Cloud Pub/Sub, and BigQuery.
Why is this correct? B. This combination provides a complete streaming analytics architecture. Cloud Pub/Sub ingests real-time game telemetry, Cloud Dataflow processes streaming data pipelines, BigQuery enables scalable real-time analytics and SQL queries, and Cloud Storage provides durable storage for raw data and backups. Why are the others incorrect? A. Cloud SQL is a relational OLTP database incapable of scaling for high-throughput analytical queries. This option also lacks a stream processing engine like Dataflow and a data warehouse like BigQuery. C. Cloud SQL is designed for transactional processing rather than large-scale real-time analytics. Furthermore, BigQuery is missing, which is required for scalable analytical querying over streaming game telemetry. D. Cloud SQL cannot scale for real-time game analytics. Using Dataproc adds unnecessary operational complexity compared to Dataflow, and BigQuery is missing for serverless data warehousing. E. This architecture relies on self-managed compute engine and Dataproc clusters instead of managed streaming processing, Dataflow, and lacks BigQuery for serverless, low-latency real-time analytics.
For this question, refer to the Mount Curt Games case study. Mount Curt Games wants to migrate from their current analytics and statistics reporting model to one that meets their technical requirements on Google Cloud Platform. Which two steps should be part of their migration plan? Choose 2. The options are: Option A, evaluate the impact of migrating their current batch ETL code to Cloud Dataflow. Option B, write a schema migration plan to denormalize data for better performance in BigQuery. Option C, draw an architecture diagram that shows how to move from a single MySQL database to a MySQL cluster. Option D, load 10 terabytes of analytics data from a previous game into a Cloud SQL instance, and run test queries against the full dataset to confirm that they complete successfully. Option E, integrate Cloud Armor to defend against possible SQL injection attacks in analytics files uploaded to cloud storage.
To arrive at the correct answer, we focus on the keywords, analytics and statistics reporting model, migration plan, choose 2.
The correct answers are option A, evaluate the impact of migrating their current batch ETL code to Cloud Dataflow. And option B, write a schema migration plan to denormalize data for better performance in BigQuery.
Why is this correct? A. Cloud Dataflow is GCP's fully managed service for unified stream and batch data processing, making it the ideal target for migrating legacy batch ETL pipelines to meet modern analytics processing requirements. B. BigQuery is designed as a columnar data warehouse where denormalized schemas significantly improve query performance, reduce join overhead, and lower operational costs compared to traditional normalized database schemas. Why are the others incorrect? C. Moving to a MySQL cluster focuses on transactional OLTP database scaling, which does not address the scalability and performance requirements of an analytics and statistics reporting system. D. Cloud SQL is a relational database designed for OLTP workloads and is poorly suited for performing complex analytical queries against large datasets like 10 terabytes, which require BigQuery. E. Cloud Armor provides DDoS protection and web application firewall capabilities for HTTP/S load balancers, not direct protection against SQL injection within files uploaded to cloud storage.
For this question, refer to the Mount Curt Games case study. You need to analyze and define the technical architecture for the compute workloads for your company, Mount Curt Games. Considering the Mount Curt Games business and technical requirements, what should you do? The options are: Option A, create network load balancers. Use preemptible compute engine instances. Option B, create network load balancers. Use non-preemptible compute engine instances. Option C, create a global load balancer with managed instance groups and auto-scaling policies. Use preemptible compute engine instances. Option D, create a global load balancer with managed instance groups and auto-scaling policies. Use non-preemptible compute engine instances.
To arrive at the correct answer, we focus on the keywords, technical architecture for the compute workloads, business and technical requirements.
The correct answer is option D, create a global load balancer with managed instance groups and auto-scaling policies. Use non-preemptible compute engine instances.
Why is this correct? D. A global load balancer with managed instance groups, MIGs, and auto-scaling policies dynamically handles worldwide traffic demand in player spikes. Non-preemptible compute engine instances ensure high availability and prevent unexpected instance terminations during active gameplay sessions. Why are the others incorrect? A. Network load balancers operate regionally rather than globally, making them suboptimal for global traffic distribution. Using preemptible instances introduces risk of sudden terminations, which causes disruption to active game sessions. B. Network load balancers are regional and cannot distribute traffic globally across multi-region managed instance groups, failing to meet the requirement for seamless global player traffic routing. C. Preemptible compute engine instances can be reclaimed by GCP at any time with a 30-second warning, which risks dropping active player connections and causing unexpected service interruptions.
For this question, refer to the Mount Curt Games case study. Mount Curt Games wants to design their solution for the future in order to take advantage of cloud and technology improvements as they become available. Which 2 steps should they take? Choose 2. The options are: Option A, store as much analytics and game activity data as financially feasible today so it can be used to train machine learning models to predict user behavior in the future. Option B, begin packaging their game backend artifacts in container images and running them on Google Kubernetes Engine to improve the ability to scale up or down based on game activity. Option C, set up a CI/CD pipeline using Jenkins and Spinnaker to automate Canary deployments and improve development velocity. Option D, adopt a schema versioning tool to reduce downtime when adding new game features that require storing additional player data in the database. Option E, implement a weekly rolling maintenance process for the Linux virtual machines so they can apply critical kernel patches and package updates and reduce the risk of zero-day vulnerabilities.
To arrive at the correct answer, we focus on the keywords, design their solution for the future, cloud and technology improvements as they become available, choose 2.
The correct answers are option A, store as much analytics and game activity data as financially feasible today so it can be used to train machine learning models to predict user behavior in the future. And option B, begin packaging their game backend artifacts in container images and running them on Google Kubernetes Engine to improve the ability to scale up or down based on game activity.
Why is this correct? A. Storing as much game activity data as feasible preserves valuable historical data needed to train future machine learning models as cloud ML technology advances. B. Containerizing game backends and deploying on Google Kubernetes Engine (GKE) modernizes the architecture, allowing seamless dynamic scaling and future cloud-native technological integration. Why are the others incorrect? C. Managing self-hosted Jenkins and Spinnaker pipelines adds infrastructure maintenance overhead instead of leveraging managed cloud improvements. D. Schema versioning manages database migration scripts but does not strategically align the infrastructure to leverage future cloud platform advancements. E. Performing rolling VM kernel maintenance retains legacy compute management overhead rather than modernizing to cloud-native containerized or serverless architectures.
For this question, refer to the Mount Curt Games case study. Mount Curt Games wants you to design a way to test the analytics platform's resilience to changes in mobile network latency. What should you do? The options are: Option A, deploy failure injection software to the game analytics platform that can inject additional latency to mobile client analytics traffic. Option B, build a test client that can be run from a mobile phone emulator on a compute engine virtual machine, and run multiple copies in Google Cloud Platform regions all over the world to generate realistic traffic. Option C, add the ability to introduce a random amount of delay before beginning to process analytics files uploaded from mobile devices. Option D, create an opt-in beta of the game that runs on players' mobile devices and collects response times from analytics endpoints running in Google Cloud Platform regions all over the world.
To arrive at the correct answer, we focus on the keywords: analytics platform's resilience to changes in mobile network latency. What should you do?
The correct answer is option A, deploy failure injection software to the game analytics platform that can inject additional latency to mobile client analytics traffic.
Why is this correct? A. Failure injection software directly simulates controlled network latency changes on incoming mobile client traffic, enabling Mount Kirk Games to validate the analytics platform's resilience under degraded network conditions. Why are the others incorrect? B. Running emulators across GCP regions tests regional availability and server load, but high-speed cloud networks cannot simulate real-world mobile network latency fluctuations. C. Delaying back-end processing tests queue handling and asynchronous execution, but fails to simulate client-side network latency or network layer transit delays. D. Collecting telemetry from real players measures existing response times passively, but does not proactively test system behavior under injected network latency stress.
For this question, refer to the Mount Kirk Games case study. You need to analyze and define the technical architecture for the database workloads for your company, Mount Kirk Games. Considering the business and technical requirements, what should you do? The options are: Option A, use Cloud SQL for time series data, and use Cloud Bigtable for historical data queries. Option B, use Cloud SQL to replace MySQL, and use Cloud Spanner for historical data queries. Option C, use Cloud Bigtable to replace MySQL, and use BigQuery for historical data queries. Option D, use Cloud Bigtable for time series data, use Cloud Spanner for transactional data, and use BigQuery for historical data queries.
To arrive at the correct answer, we focus on the keywords: technical architecture for the database workloads, business and technical requirements.
The correct answer is option D, use Cloud Bigtable for time series data, use Cloud Spanner for transactional data, and use BigQuery for historical data queries.
Why is this correct? D. Cloud Bigtable is designed for high-throughput time series telemetry data. Cloud Spanner provides globally scalable ACID-compliant transactional gaming data storage, and BigQuery serves as the analytics warehouse for querying historical game data. Why are the others incorrect? A. Cloud SQL is poorly suited for high-scale time series ingestion, and Cloud Bigtable is a NoSQL store optimized for fast key-value lookup rather than ad hoc analytical queries on historical data. B. Cloud SQL lacks the global scale and high availability needed for Mount Kirk's transactional workloads compared to Cloud Spanner, and Cloud Spanner is inefficient and costly for running analytical historical data queries. C. Cloud Bigtable is a NoSQL key-value store and cannot directly replace a relational MySQL database needing ACID transactions, as Cloud Spanner is required for globally distributed relational transactions.
For this question, refer to the Mount Kirk Games case study. Which managed storage option meets Mount Kirk's technical requirement for storing game activity in a time series database service? The options are: Option A, Cloud Bigtable. Option B, Cloud Spanner. Option C, BigQuery. Option D, Cloud Data Store.
To arrive at the correct answer, we focus on the keywords: managed storage option, storing game activity in a time series database service.
The correct answer is option A, Cloud Bigtable.
Why is this correct? A. Cloud Bigtable is a fully managed NoSQL wide column database optimized for high throughput, low latency workloads, making it the ideal choice for storing time series data such as game activity. Why are the others incorrect? B. CloudSpanner is a globally distributed relational database designed for transactional OLTP workloads, not specifically optimized for high-volume time series data ingestion. C. BigQuery is an enterprise data warehouse designed for large-scale analytical processing, OLAP, not a dedicated low-latency time series database service. D. Cloud Data Store is a document NoSQL database designed for application state and entity transactions, not tailored for scalable time series activity logging.
For this question, refer to the Mount Curt Games case study. You are in charge of the new game backend platform architecture. The game communicates with the backend over a REST API. You want to follow Google recommended practices. How should you design the backend? The options are: Option A, create an instance template for the backend. For every region, deploy it on a multi-zone managed instance group. Use an L4 load balancer. Option B, create an instance template for the backend. For every region, deploy it on a single zone managed instance group. Use an L4 load balancer. Option C, create an instance template for the backend. For every region, deploy it on a multi-zone managed instance group. Use an L7 load balancer. Option D, create an instance template for the backend. For every region, deploy it on a single zone managed instance group. Use an L7 load balancer.
To arrive at the correct answer, we focus on the keywords: Game Backend Platform Architecture, REST API, Google Recommended Practices.
The correct answer is option C, create an instance template for the backend. For every region, deploy it on a multi-zone managed instance group. Use an L7 load balancer.
Why is this correct? C. REST APIs use HTTPS, requiring a Layer 7, L7, load balancer for global routing and SSL termination. Multi-zone managed instance groups ensure high availability across multiple zones in each region. Why are the others incorrect? A. Layer 4, L4, load balancers operate at the transport layer, TCP/UDP, and lack HTTPS, application-level routing features suited for REST APIs. B. Single-zone managed instance groups lack high availability across zones, and an L4 load balancer does not provide application layer routing needed for REST API traffic. D. A single-zone managed instance group introduces a single point of failure within the region, failing Google recommended high availability best practices.
You need to optimize batch file transfers into cloud storage for Mount Curt Games' new Google Cloud solution. The batch files contain game statistics that need to be staged in cloud storage and be processed by an Extract Transform Load (ETL) tool. What should you do? The options are: Option A, use SUDL to batch move files in sequence. Option B, use SUDL to batch copy the files in parallel. Option C, use SUDL to extract the files as the first part of ETL. Option D, use SUDL to load the files as the last part of ETL.
To arrive at the correct answer, we focus on the keywords: optimize batch file transfers into cloud storage, game statistics, extract transform load, ETL, tool.
The correct answer is option B, use SUDL to batch copy the files in parallel.
Why is this correct? B. Using SUDL with parallel multi-threading and multi-processing capabilities enables batch copying of files simultaneously, significantly optimizing transfer performance into cloud storage. Why are the others incorrect? A. Sequential file transfers process one file at a time, which is inefficient and fails to optimize transfer performance. C. SUDL is a command line tool for managing cloud storage objects, not an ETL engine designed to extract data. D. SUDL is designed for storage data transfers, not for executing the final data loading stage of an ETL workflow.
You are implementing Firestore for Mount Curt Games. Mount Curt Games wants to give a new game programmatic access to a legacy game's Firestore database, access should be as restricted as possible. What should you do? The options are: Option A, create a service account, SA, in the Legacy Games Google Cloud project, add a second SA in the New Games IAM page, and then give the organization admin role to both SAs. Option B, create a service account, SA, in the Legacy Games Google Cloud project, give the SA the organization admin role, and then give it the Firebase admin role in both projects. Option C, create a service account, SA, in the Legacy Games Google Cloud project, add this SA in the New Games IAM page, and then give it the Firebase admin role in both projects. Option D, create a service account, SA, in the Legacy Games Google Cloud project, give it the Firebase admin role, and then migrate the new game to the Legacy Games project.
To arrive at the correct answer, we focus on the keywords Firestore, programmatic access to a Legacy Games Firestore database, as restricted as possible.
The correct answer is option C, create a service account, SA, in the Legacy Games Google Cloud project, add this SA in the New Games IAM page, and then give it the Firebase admin role in both projects.
Why is this correct? C. Creating a service account in the Legacy project and adding it to the New Game project's IAM page enables secure cross-project authorization. Granting the Firebase admin role provides the necessary permissions to manage Firestore data while avoiding overly broad administrative roles. Why are the others incorrect? A. Granting the organization admin role violates the principle of least privilege by bestowing full control over the organization. Additionally, creating two separate service accounts is unnecessary for setting up cross-project access. B. Assigning the organization admin role grants excessive administrative control over all organization resources, violating the requirement to keep access as restricted as possible. D. Migrating the new game into the Legacy Games project creates unnecessary administrative overhead and architectural churn. Cross-project IAM authorization efficiently handles database access across distinct projects.
Mount Curt Games wants to limit the physical location of resources to their operating Google Cloud regions. What should you do? The options are: Option A, configure an organizational policy which constrains where resources can be deployed. Option B, configure IAM conditions to limit what resources can be configured. Option C, configure the quotas for resources in the regions not being used to 0. Option D, configure a custom alert in Cloud Monitoring so you can disable resources as they are created in other regions.
To arrive at the correct answer, we focus on the keywords limit the physical location of resources to their operating Google Cloud regions.
The correct answer is option A, configure an organizational policy which constrains where resources can be deployed.
Why is this correct? A. Organization policies provide centralized control over resources. The resource location restriction constraint allows administrators to strictly restrict the geographic regions where Google Cloud resources can be created. Why are the others incorrect? B. IAM conditions grant or restrict permissions based on attributes like request time or resource tags, but they cannot enforce organization-wide location constraints on resource deployment. C. Resource quotas manage consumption limits to prevent quota exhaustion and control costs. They are not designed to restrict geographic resource placement across all GCP services. D. Cloud monitoring custom alerts provide reactive notifications after events occur, which cannot proactively prevent or block the creation of resources in unauthorized regions.